Good morning, everybody. Well, it might not be morning for you, it might be nighttime, or whatever time it is you're watching this. It is time to study for the quiz. Hopefully you've done a little bit of a review for yourself. If not, this is a good way to start. So let's talk about the very first thing that you need to know for this quiz, and that's force. Now, force is anything that causes an object to undergo a change. Any kind of change. And there's many different kinds of forces. So I listed a few as an example on the slide. Thrust increases the velocity, and air resistance decreases velocity. So air resistance is going to slow you down. It's going to push against whatever is traveling. Gravity is another type of force. It's a force that acts between two objects. For example, you and the Earth. The Earth is pulling you onto the ground. It's keeping you on the ground. That way you don't float up into space. So the bigger the object is, the more gravity it has, the more gravitational force it has. The smaller the object is, the less gravity it has, the smaller its gravity is. So the guy that came up with a bunch of ideas when it comes to physics is Sir Isaac Newton. He was a physicist and a mathematician. He described gravity, he invented calculus, but most important for us, he came up with the 3 laws of motion that we've been studying for the past week or so. So, let's get to his first law of motion. Very first law is this. Oh, nope, that's the second law. Mr. Engling lied. Let's try that again. First law. Here you go. First law. Objects with balanced forces acting on them will stay at rest or stay in motion. That means something is going to stay at rest or something is going to stay in motion unless it is interrupted. So something is going to stay resting unless it gets hit and gets changed by a force, or something is going to stay in motion until something stops it. So this outside force can affect speed, it can affect direction, it can affect shape, it can affect all of those things. Now, when we are talking about the first law, there's one important vocabulary word you need to know, and that is inertia. Inertia is the resistance of an object to change its motion. An object is going to resist changing. An object is going to resist trying to move. An object is going to resist trying to stop moving. Inertia is what describes that resistance. So the more mass something has, the more something weighs, the bigger it is, the harder it is to stop. The smaller it is, the less inertia it's going to have. That's why if I throw a cell phone at you, you're probably okay to catch it. It's small, it doesn't have a lot of inertia, it doesn't take a lot of effort to slow down and catch. If I throw this table that the computer is on at you, it might be a little harder. It's bigger, it has more mass, and because it has more mass, it has more inertia. So it's going to take more effort to slow it down in order to catch it. Alright, so that is the first law. On to the second law. So the second law deals with what happens when an outside force acts on something. Now, I showed you this slide that has all these descriptions of the second law. All these describe the second law. Direction of an object's acceleration is the same as the direction of the outside force. The magnitude of the object's acceleration is in direct proportion with the unbalanced force. I'm not going to read all that. You guys don't really need to memorize all of this. What I care about you memorizing is the formula. What the second law is really about is this right here. This is your bread and butter of the second law. The second law of motion tells you that force is equal to mass times acceleration. This right here is the second law. Force is equal to mass times acceleration. So, we measure force in newtons. That's just a unit that we use for force. For weight, we use for mass, we use kilograms. For speed, we use meters a second. For distance and displacement, we use meters. For force, we use newtons. So, a little bit more about the second law. Another important vocab you need to know, or vocabulary word you need to know for the second law, is friction. That's a force created by two things sliding past each other. So, this force is always against motion. If my motion is going this way, friction is going to go against it. So if I have, if I have this glass here, and this is my table, if I'm pushing this along the table, my motion is going in this direction. Friction is always against motion, so friction is going to be pointing in that direction. It always pushes opposite to motion. Alright, weight and mass. Two important words, and you need to know the difference here. Weight and mass are not the same thing. Mass measures how much matter an object has, and weight measures the force acting on that matter. That means your mass is never going to change. Your mass is measured in kilograms, and your mass tells you how many atoms are inside of you. What's your mass like? How much matter is there? Weight is affected by gravity. Weight is gravity acting on your mass. That means your weight is going to change depending what planet you're on. So you will not weigh the same on Earth as you would on the moon. Your weight's going to be different. Your mass is still the same. You still have the same number of atoms, but your weight will be different because it is affected by gravity. Alright, so we are almost done going through all these slides. We have really one more slide, and that is Newton's third law of motion. The third law says for every action there's an equal and opposite reaction. When you push on something, that something is going to push back on you. Force happens in pairs. There's always an acting force and a reacting force. So when I push on this laptop, it pushes back a little bit. When I push on this phone, it's going to push back a little bit. When I push on this table, I go back in my chair because the table is also pushing back at me with an equal force that I'm giving it. Alright, this is what allows us to walk. As you walk, your feet push into the ground, you're pushing down, and the ground pushes back up. This upward push allows you to walk. It's as simple as that. It's all about Newton's third law. So there you are. Those are the laws. First law of motion, second law of motion, and third law of motion. Now, it's time to change with a little bit of computer magic. And boom! Alright, so a little bit of change here. Alright, time for some practice problems. So here, this is a really easy one. How much force will Mr. Engling have to kick this 10-kilogram ball to accelerate it by 5 meters a second? So, we have to remember that force is equal to mass times acceleration, which means we don't know the force, so we'll call that F. And we know we have a 10-kilogram ball multiplied by 5 meters a second. That means our force is going to be 50 newtons. Remember to include units. I want units. I will take off points if I don't see units. Alright, let's trash this real quick. And then we can move on to the next problem. Alright, so next problem. Let's see if we can make this a little harder for you all. I think you're ready for that. Alright, so for this problem is all about airplanes, and I'm getting my calculator ready here in case I need it. Alright, so an airplane with a mass of 1,200 kilograms starts from rest and accelerates. The aircraft is pushing forward with a thrust of 3,400 newtons. There's a constant friction of 400 newtons on the plane. What is the acceleration of the airplane? So we need to figure out what the total force is here. So remember, like I said before, force is equal to mass times acceleration. I'm sorry, that's a messy M. In this case, our force is 3,400 newtons. That's our total force. But we have friction, going against total force. Remember, if motion is going this way, friction is always going to go in the opposite. Since this is our total force, we need to subtract the friction from it. So we need to subtract 400 newtons, which is going to be here, so you can see. We need to subtract from it. So you can see here, this is 400 friction. So now we know our total force, or not our total force, but our force of just the airplane is 3,000 newtons. Alright, so let's see what other information we can figure out here. We know that the mass of the airplane is 1,200 grams. Okay, oh, kilograms, not grams. An airplane's not going to be measured in grams. And then what is the acceleration? So we're looking for the acceleration here. So we'll divide both sides by 1,200 kilograms. And then we are going to get the answer, which in this case is, I'm going to take out this calculator because it's too early in the morning to do this math in my head. 2.5 meters a second. Boom. Oh, 2.5. There we go. That doesn't get a comma, but close enough. Alright, there we go. There's that problem. Let's do another problem. Everybody loves doing math problems. Especially this early in the morning. I know you're excited. Let's go down and do another one here. Okay, nope. Let's just go back to the one that I picked out here. We're doing this one. And I'm going to erase this real quick. Oops. Let's try that again. And we are going to cut it. Alright, good enough. I can draw on this now. Alright, so Mr. Anglin's on another rocket skateboard. That crazy Mr. Anglin, why is he always on a skateboard? His force coming down the hill is 25 newtons. The force of air resistance on him is 5 newtons. The friction pushing against the skateboard is another 6 newtons. Mr. Anglin's mass is 75 kilograms. What is his acceleration? What we are going to need to use... Ooh, wow, that's hard to see. We're going to need to use this formula again. I'm going to up my size here. So, first we need to figure out what my downward force is here. Now, the issue is, I know that I'm coming down the hill with 25 newtons. But I have air resistance that's pushing back on me, and I have friction from the ground pushing back on me. So this is the air resistance, and this is the friction. So those are both pushing back on me. So my force that I have to work with really is only 14 newtons. Let me make sure that's right. Yeah, that's good enough. That's right. 14 newtons. So I weigh 75 kilograms. Maybe I do, maybe I don't. But for this problem, I do. And I need to know my acceleration. So then we divide both sides by 75. And that means my acceleration is going to be some number that my magical calculator is going to tell me. 14 divided by 75 is... It's 0.186 repeating. And this is going to be in meters per second squared. Alright guys, that's all you really need to know for this quiz. You'll have some math problems, you'll have some questions about the second law of motion, you'll have some questions about weight and mass, and some questions about force. Make sure you know those things, and good luck studying. I'll see you on the quiz.